And music didn't stop. Right, everybody, welcome. This is the day one of the Advent of Code 2020. So what I'm going to try and aim this at is I'm tutoring a lot of students that have never coded before or haven't done anything beyond sort of the toy examples you get given when you're learning something. So I'm going to try and aim this at people that have either never programmed or are very early into programming and haven't really figured out how to break down problems. That's not to say that I will be able to break down the problems, but it just, it's going to be very low level. So if you've never coded before and never even used Python before, I'm going to try and explain some of that stuff while I do it. So this is Advent of Code. I'll send it in the chat. So every year they do a sort of Christmassy themed set of problems, and these problems are broken down into a first half that's normally much easier but can still be really computationally difficult, and then normally you'll get some sort of puzzle input and you'll run your code, and if you get the answer correct you'll win a star. So the goal is to collect all these stars, but on top of that it'll also reveal the second half of the challenge. Now normally the second part, hello Sam, nice to see you. The second part of that challenge is normally some sort of twist on the first half that'll make you use something slightly more advanced, or it'll make you sort of tweak what you had, and it'll basically change the assumptions you made about the program. So just like in real programming problems, things get a little bit more complicated and you have to react to them. I'm going to try and spend about an hour on this, and I'm going to aim to do it at 11 AM each day. I'm not sure I should say that while it's being live streamed, but we'll see how that goes. So yeah, feel free to follow or whatever, but I'll be tweeting out each time I do it, and it's all going to be recorded and uploaded here and on YouTube anyway, so don't worry about that. But yeah, let's get started. So let's begin our coding adventure. So day one of Advent of Code. So day one, report repair. After saving Christmas 5 years in a row, you've decided to take a vacation at a nice resort on a tropical island. Surely Christmas will go on without you. The tropical island has its own currency and is entirely cash only. The gold coins used there have a little picture of a starfish. The locals just call them stars. None of the currency exchanges seem to have heard of them, but somehow you'll need to find 50 of these coins by the time you arrive so you can pay the deposit on your room. To save your vacation, you need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Before you leave, the elves in accounting just need you to fix your expense report, which is my puzzle input. Apparently something isn't quite adding up. Specifically, they need you to find the 2 entries that sum to 2020. And then multiply those 2 numbers together. For example, suppose your expense report contains the following. In this list, the 2 entries that sum together to make 2020 are 1,721 and 299. Multiplying them together produces 514,579, so that is our correct answer. Of course, my expense report is much larger. Find the 2 entries that sum to 2020. What do you get if you multiply them together? And here is my puzzle input. So much bigger, so we're going to need something that reads in all these numbers. There's a lot of numbers there. Okay. So I'm also using REPL.it. So if you don't have your Python environment set up, you can use REPL.it to basically create a lot of programming environments. I'll be using Python, and if you go on that link I just sent in the chat, you should be able to see this code whenever it's completed or somewhat live. You might have to keep refreshing it. Okay, so I'm basically gonna, first thing I do is, look at all this, and there's a lot of information there that's completely irrelevant. Basically, everything up here is irrelevant. This bit is kind of relevant, and it also gives us our first test case. So we can try with these as our test case, and I'm going to copy this. This is a good comment that's going to summarize everything. So in this editor, if you press Control / or if you press on Mac, you press that Command /, it'll comment however this language comments. So in Python, we use this hashtag, and that basically means if we run this code, nothing will happen with that, whereas without that it'll try and run it as Python code and it'll error. So it's useful for me to keep that here so I don't have to keep swapping back to the other. I'm not going to use this for a while actually, so I don't have to keep swapping back to over here. And I'm going to grab this set of numbers for now. Would I recommend REPL? So I actually wrote about that in a blog post the other day. Google Colab is great, and it's really good if you're used to that sort of notebook style, but if people are very new to programming, I think even explaining notebook style is a little bit weird, so it's useful to write that sort of markdown alongside code cells. I'd say it's a little bit more complicated, especially for these little tasks. If you just want an online one, I'd say, oh, it's weird. If you're doing data analytics type stuff or anything that requires you to sort of produce a nice report at the end, then I would suggest Google Colabs. The disadvantage there is that sometimes, well, Google Colabs uses your Google Drive, so if you're dealing with like big data, not big data, but like big, large files or anything that you're sort of concerned about, then you're going to be using your own account for that. Obviously the same would apply to REPL anyway. But yeah, I think REPL's a bit simpler and has maybe a bit more variety than Google Colabs, but Google Colabs probably has better resources. So for this challenge, I would suggest REPL, but Google Colabs is great as well. So for the input, we're going to multiply them together, and that's our answer. So we know that we need to find. I'm going to keep all that actually. I'm already thinking there's definitely like a clever mathsy way of doing this, but I'm not sure what it is. So to start with, let's just get something that's going to iterate over the entire list and just produce all of the sums. So for now, I'm going to just call it input. No, not my input. So this is what's called a variable, and then the equal sign is an assignment. So whatever we write on the right-hand side of that equals will be stored in the variable on the left-hand side. So when we run that, we can actually access that variable later by typing it out, and it'll return that value. We can do all sorts of stuff with this. We can multiply it, and that's not multiply. We can add it to itself, and we'll get 12. So in Python, we've got all that basic maths. We can do 3 plus 3, 3 minus 3. Multiplication is done with an asterisk, and division is done with the /. And there's a bunch of other stuff there, but let's not worry about that for now. So instead of, I don't actually want just the value 6, I want all of these values. So what I'm going to do is create a list. Now a list is a set of values that have the same type. So I'm going to type all of my numbers out in here. Make sure I get the numbers right. 9, 9, 6, 7, 5, 1, 4, 5, 6. Yeah, so we just got a note that my binder on GPython notebooks can be useful. Again, yeah, I'd say it is a bit elaborate. It could be, for very early, whenever someone's trying to learn Python, I feel like there's this tricky part where either someone that knows more about Python needs to provide them an environment, or they don't really know how to start, or they end up running like the Python REPL in terminal and don't know how to save and run code. So I advise something, keep it as simple as possible. Do whatever lets you start writing Python and saving that Python file somewhere and running that Python file. And I think REPL's good just for pressing that run button. Okay, so we've got a list here. So now if I run this, do my input, we've got that list of those values. So what we're looking for here in sort of a brute force, I don't need this anymore. So I'm starting with like a brute force method where I'm going to iterate probably over every element in the list and add it to every other element in the list. I'm sure there's a better way. I'm thinking maybe we could sort the list instead, and then we could iterate from the beginning and end. Oh, I don't know, that doesn't sound better either. I'm not too sure. No, that makes, we'll look at that later, but I'm going to try and just brute force it for now. So we can use what's called a for loop. So this will let us basically iterate over a list. So we can say for item in my input, and we have to use a colon, and we have to indent here, so we have to tab indent to get inside here, but we can print that item. So this is sort of our first slightly more complicated structure. I'll just take this to mention that Python is dependent on these tabs to know what it's running within something else. So we can't not have that tab there. That's sort of invalid Python. So that can be sort of a common gotcha for early Python users, because most other languages don't care about that kind of stuff. They'll use brackets and semicolons and all sorts of extra characters to do the same thing, to sort of deal with that scope problem. Python doesn't do that. So if we run that now, we print out each of these one at a time, so that's cool. What I'm going to do is write another for loop in there, and that will let us iterate over both. They can't both be item, so I'm going to call them x and y. And what this will do is let me print out all my combinations of these two variables. So you can see we're in that first for loop, so x is equal to 1721, and okay, I scrolled down a little bit. I was like, why is that starting on the next one? And then you can see it iterates through on y for all the combinations until it finds it. That doesn't make sense. My brain's still processing it. So it's iterating through this entire list, and then when it's finished iterating through that list, we go back to this outer for loop where it increments that one to 979. So we've got all our combinations now, so we could just try adding them together. Now potentially we have a problem already because of the, what would it be? This has got like a, what's called an n squared complexity, I think. So even though we've only got 6 inputs, we've now got 6 times 6 potential combinations, which means when we do look at our puzzle input, that's probably going to be something like 100, which means we're going to, oh no, it's a big input. Maybe 100, maybe more, which means we're going to have 10,000 combinations, which is probably won't really be a problem. So we might get away with brute forcing it now. But I'm slightly concerned that the second part of this problem is going to be, it's going to punish us if we try and brute force it. So I'm just trying to be aware of something we can do there. But yeah, I'm going to run all of these together now. And I'm going to print the x and y for each one as well. So somewhere here, there's going to be a 2020, which we did say in here. It's 1721 and 299. 1721, 299. So there it is. So we've got our answer there. We don't want to have to look through that list on the right-hand side to try and figure out where that is. So we probably don't want to print anything unless that's true. So this is where we need some form of selection. So similar to our for loops, there's something in Python called an if statement that you might have heard about. So we can check if something, we have to check some sort of true or false condition. So I might say, for example, is 2 equal to 2? If it is, then we print yes it is. Something like that. And again, we're using that indentation there to control what's inside the if statement. We have to have that colon at the end. So if I run that, I'll clear. If I run that, it just says yes it is. Obviously 2 is always equal to 2. But we can do more clever things here. So we could say is 2 less than or equal to 10, for example, which it is. We can also add extra conditions here. So we can use an else to say no it isn't, just to print out. Oh dear, let's not do that. The whole series is just going to be me saying oh dear. So is 2 greater than 10? No it isn't. So whatever's up here needs to evaluate to what we call a boolean in Python. So that's a true or false value denoted with a true with a true with a capital T or false with a capital F. So if we do anything like this, it'll actually return true or it'll return false. 2 is greater than 10, returns false. We also have a Boolean comparison called not equals, using that exclamation mark. So we can check if 2 does not equal 2, which is false. And that's kind of the fundamentals of if statements. I don't want to get too far away from what I'm trying to solve, but I don't want to also just throw out an if statement and not explain it. So what I can do here is I can say if x plus y is equal, and we have to use double equals because the single equals is for assignment, so double equals. So if x plus y is 2020, then we want to print x and y, and we want to show that they sum to 2020. Huh, interesting. So we have two solutions, but they're the same solution, so adding 1721 to 299 and the other way around. So that's pretty much, we're done there, assuming that we're not going to trip up on this complexity issue. If we did want to try and do something that would run quicker, my thinking is that we would perhaps sort this list, and we would be able to look at like the first and last elements in the list and see if that number was bigger or smaller than 2020. And then there are potentially some numbers that have sort of a lower bound of what they could be multiplied by. So if the smallest number in our list is 300, no, it's adding them together, isn't it? I don't know. I'm going to leave it for now and see if we get away with it. So next thing we need to do is, instead of reading this list in here, we want to read it in, because I don't want to type all of this list in one by one. That's going to take too long. So what we can do in REPL is we can add a file here. We can just call that something like input.txt, and in there I'm going to paste this test case. Oh, I also didn't multiply the list. Let's multiply the list first. Something you've not touched on yet is a notion of functions. So there's a def keyword, short for define, and in there we can do something like this, to multiply numbers. So all that is a function name. It's going to take two numbers. So these are variables I'm calling num1 and num2. Then colon at the end of pretty much anything we do, for loops, if statements, we put that colon. And here every function can return something, so I'm going to just return num1 times num2. And what I can do is call this function. I think I've skipped over a lot there. Let's go. So you would write def, then you would write a function name, use open brackets in the definition, and you also use those open brackets when we call this function later. In here you put any parameters you might want, comma separated, and then in here you can do whatever you want. So call function called, and we can call that as many times as we want. So if I run function name and give it some parameters, it'll run that function called. Function name. So we're calling that with the brackets, passing it any parameters we said we would. That can be anything. It can be a string with quotes around it. It can be numbers. It can be a list. It doesn't really matter. I don't know if it'll let me send nothing. No, it doesn't like that. So yeah, in a similar light, we can call that new multiply numbers function with any two numbers, and it'll just return those numbers multiplied together. So it's not really necessary, because we could obviously just run 2 times 2 and we get the same answer, but these become sort of the building blocks of everything you want to do. For example, this could be its own function that iterates over that list, takes that list as a parameter, but I don't want to sort of cloud that up right now. So I'm going to leave this multiply numbers out, and we can call print, I'm going to say our answer, comma, and then call that function there, multiply, oh, it doesn't exist yet, multiply numbers, x comma y. And that's complaining because it doesn't exist yet, I believe. So I'm going to move this function up here, and function name no longer exists. So now when I run it, we get our answer as well, which we've seen in our test case there that is correct. So yeah, I'm going to write some comments out. Input list, function to multiply numbers, and iterate over our numbers to find our answer. I don't know what to say that's better than that. Sometimes it might be common to sort of describe this if statement if it's a bit confusing. When is this condition true? So we might say like if x and y sum to 2020, Might be easy to read that now, but sometimes these if statements can be quite complicated, so that can be a good pattern to get into. Okay, so we've got these numbers here. Next we're going to try and read these into a list so that everything continues working. This is something that I always forget how to do, and one of the big cool parts of coding is that you can just Google things and use what other people have written already, and that's not really a frowned upon thing. So don't be afraid to Google stuff if you get stuck. So let's see, what do I want to do? Read text file line by line into list Python. You can see I've been here before with open file name. Okay. So I'm just going to try some of this stuff. So our file name here is input.txt, and that will give us this lines variable. I might have to define that outside. So let's say my input is an empty list currently, but I'm going to fill it with the red lines here. So now, well, it should run. Oh no, that doesn't look good. My input. Okay, it's still got its new lines in there. So this will strip those new line characters for us. So that's read them all in as strings, and in strings, our new line character, so there's a character that happens when you press enter, and we don't want that in there. We want our numbers. So we could iterate over this list again, strip out those extra characters, convert it to an int, but there might be something that does it for us already. So I'm going to try and make sure that's indented, and line for line in file. It's a little worrying that the rest of the code isn't running now. That's the same. Is that, oh, there we go. Just took a little bit of time. Okay, cool. So slightly closer, but now things are, so you see these quotes in here, that means that they're strings. So if, for example, I do 12 as a string plus 12 as a string, you'd think the answer would be 24, but it's actually 1012 as a string. So this is getting onto a notion of types. So there's a function called type that will explain the type of whatever you put in. So that says it's an integer. So an integer is a whole number. So 12.5 isn't an integer, but 12 would be. 12.5, while we're on it, is something called a float. So that means it's got this floating decimal point, so we can sort of represent decimal values to a degree. To denote strings, we use these quotes. So that's a string type. Those can be, they have their own sort of functions, so if you add strings, it concatenates them instead of adding the numbers. So that's Python trying to help you out there. I'm not sure what it'll do if I just, yeah, just complains. Okay. We can pass it lists with these square brackets. We can pass it dictionaries with these ones. We can pass it a boolean with one of those true or false values. So there's loads of stuff there, and there's a lot to get into there. But for now, all we need to know is that we've got strings at the moment, and we want integers. So we need to convert those strings to integers. And Python has a function that does this called int. So if we do the string 123, it'll convert that into an integer without those quotes. So I'm thinking if I wrap this bit, I don't really know what it's doing, but if I wrap that bit in an int function, we might get away with it. Hey, there we go. So now my input is a list of integers like it was here. So I can delete that line now, read our input. And we have to create this out here, because if we don't, then I don't think my input will exist outside of that. Okay, maybe it does. It's smarter than I am, apparently. So don't need that my input bit. So my input can be declared there, but still read in the rest of the file. I guess that's probably to do with this with stuff, but I don't know why that's happening. Okay, so now we're ready to try with our bigger input. If you press Control-A, you can highlight everything on the screen at once, and we can paste it in here. Okay, we've got 200. So that's going to be, what is it, 400,000, 40,000? That's not too bad. It might run that. Let's have a look. Oh, that was so quick. All that worrying for nothing. So let's, if I get rid of this if statement just for a second, we can see how, just how many things are being calculated there as incorrect answers. So that might make it take a little bit longer to show because the prints are a bit slow. But yeah, as you can see, there's like 40,000 things being added together. Oh, that's still not too bad. Okay, I was worrying for nothing. I guess I was worrying because this is supposed to be sort of like a coding challenge, so you're supposed to show off, but I feel like if you can make it work with brute force, you can make it work. So here's my answer. Don't know if it's correct, but it looks good to me. That looks like it adds to 2020, so let's give it a go. So we put that input in here. Boom! Good work, everybody. We got it. So now we can continue to part 2, and that will basically move us on to something that's probably going to punish me for the way I did that before. But yeah, that's all good. So that's task 1. What I'll probably do is, before I modify anything, I'll try and comment that code out as pass 1 or modify it as part 1, just so I can share this one file with everybody. Okay. So part 2, the elves in accounting are thankful for your help. One of them even offers you a starfish coin they had left over from the past vacation. Perfect. One step closer to that hotel room deposit. They offer you a second one if you can find 3 numbers in your expense report that meet the same criteria. Okay. Using the above example again, the 3 entries that sum to 2020 are 979, 366, and 675. Multiplying them together produces a much bigger number that I'm not going to try to read. Okay, so this might be okay, but knowing that the puzzle input is still 200, that means that instead of 40,000, we're going to have a bigger number, 8 million. I don't think that's too bad. We might get away with it, but obviously we're going to have to modify our original code slightly. I kind of feel like I might get away with this just by adding another for loop and modifying this multiply numbers function. So let's modify this input back to our test case because I don't need to see everything going on there. Okay, and let's wrap this up in a function so that we don't lose that. So let's do def find 2 nums, and that's going to take a list, my list, and I'm just going to wrap this whole function in there so that we don't lose it, because then my next answer is just going to be find 3 nums to find our 2 numbers. And then we can add a new one that's going to be a modification of that, but for finding 3 numbers. I'm just going to rename it find 3 numbers, but they're both going to take a list. And then I'm going to have to call that function. So if I call find 2 nums and my input, I should get the same answer we were getting before. And I'm going to copy this test case just so I don't have to keep jumping around. So part 2 test case. That's not what I want. It's not what I want, Apple. And again, Control Shift to wrap that all in a comment. Okay, so that's all good. I'm going to move that up here, part 1. And I'm just going to comment it out for now. So we want to call a find 3 nums method. So my modification here would probably be for z in my input. Do the same thing we had before. Make sure we indent this all again. And now we have 3 things that we're going to iterate over instead of 2. And we have to add them all together. and we need a new multiply numbers function that multiplies everything it gets passed. So I think I could let a Python function take any number of inputs. So we can change the number of, we can have Python functions that take any number of arguments. So if I modify this using args, and I think I can just iterate over the args and multiply them all together. I don't know how I'm going to do that. So if in here I print out what args is, multiply numbers 1, 2, 3. So you can see we've got all those arguments there. We can do, how am I going to multiply all these? I'm trying to be clever, but I'm not that clever. Is there a list product function? Or I guess I could reduce. That's kind of weird, but okay. I'm going to do that just because we'll do another for loop. But this is very unnecessary. We could just write another multiply function, or we could just literally just write the line num1 times num2 times num3. But I'll see if I can do this. So total equals 0. So just a variable that we're going to iterate over these arguments for num in args. I'm just going to print them for now just to check that that's doing what I think it's doing. And we can't return that anymore. If I do multiply numbers 1, 2, 3, cool, it prints them out one at a time, so I can do, this needs to be my first arg. So in a list you can access individual items in the list using this square brackets notation. So if we have like test equals 1, 2, 3, 4, we can access the first element in that list. You would think with a 1, but in computer science we count from 0. So the 0th index refers to that element 1. The first index refers to that second element 2. So slightly confusing there, and people will get annoyed by that all the time. I'm just going to turn down my audio, sorry, because I'm seeing that it's clipping out. So what we can do is we assume that our first argument is a number that we're going to want to multiply by, which we're kind of safe in doing here because I don't think there's a 0. Well, we'll never find a 0 for this case anyway. Then we're going to iterate over that. Oh, it needs to start with the second one. How does this person do that? For I in L. Okay, I'm going to set this to 1 instead, and then I can do total equals num times total. So that should iterate over them and multiply for me. So if I do multiply numbers 1, 2, 3, I need to print total. And that needs to not be indented. So again, multiply numbers 1, 2, 3. Cool, 6. So now we can use this multiply numbers function with as many inputs as we want, which means we don't have to write a separate multiply numbers function to multiply 3 numbers. So this can now just take a z as well. And now we can call find 3 nums with our list. Oh, my input. I didn't modify these to use their local variable, so I'm going to modify them now. Cool. What's going on here? It's finding cases where x plus y is 2020, but we want x plus y plus z. Okay. They should all be the same answer, but there's 6 different permutations of them, so yeah, that's fine. Okay, so we've got our answer for our test case, so that's looking cool. So again, I'm going to try putting in our full case. But I feel like this might take a long time. But hopefully it doesn't. Oof, doesn't take that long, but we still got it. It's definitely much slower than before. You can even see how long it took to sort of load in the other 6 cases. So it's not, maybe I'm underestimating computers, but yeah, it's not too killer, but it could be a problem. You know, if it got a little bit bigger, we would need to do something a bit more efficient. That's the right answer. Boom! Thank you for joining me on my coding adventure. That's day 1. I mean, I don't know if anyone has any other questions or any ideas on how we can modify this. We can do, but you know, it doesn't need to be over-engineered. So I'll probably leave it there. I'll give you a couple of minutes to ask any questions if there are any, or if anyone has any ideas. I'm sure there's something more clever we could do, where we could like sort the list and then iterate through it, you know, like if we do something like this, we got our list of numbers, I don't know, 2, 10. Thanks. Yeah, I don't know. That's already sorted. Sorting's less complex. I'm not going to go, I don't want to do it. It worked, so we don't need to do anything more complicated. It took a couple of seconds. So yeah, I'll leave it there. Thank you everyone for watching. It'll be on YouTube, it'll be on Twitch as a highlight, and I'll tweet it out. And I'll share this just in case you don't have the rep all. You can copy the code there if you want. Not copy, learn from and enjoy. Okay. Bye bye everybody. Good work. We did it.